Alright, welcome back class. This is going to be test preparation video. So test review, test study sheet, whatever you want to call it. You should have a piece of paper and you should take notes and then you should study. You can study today, you can study tomorrow. We plan to take the test on Friday. If you have questions as you're studying, look in the book, read everything carefully. If you still have questions, I guess I'll say this, if you still have questions you can let me know. I will try to answer them between now and Friday morning. Alright, so the first thing you should know is you should know how to find the volume of a cylinder. And that can be found in lesson 62. So it also has some detailed instructions and you must follow those detailed instructions, or you will get at least 1 point wrong. So read the problem, read it carefully, do what it says. Volume of a cylinder, that's lesson 62. Alright, number 2 comes from lesson 69 and it is similar to example 2. So example 2 on lesson 69. And I'm going to repeat these maybe about twice just to make sure that we're getting them. Alright, number 3. You can turn in your book, your textbook, look at lesson 71. And I should have said to get your textbook out at the beginning, but have it in front of you, have your piece of paper as well. Lesson 71, you are asked to do a simple translation, and it is similar to example 1A, which is not hard to do. You are going to need graph paper. I'll send the graph paper with the test. You use the graph paper, draw your coordinate grid, and you don't have to do both X and Y if you know it's just going to be in half of it, but let me know where 0 is, or you need to at least know where 0 is, so you could make it like this and just, okay, here's 0 and 0, now you're just concerned about the positive quadrant, if that's all you need. But use graph paper to do these translations and do what it says. If it says label, so find the coordinates and list them. Just make it as clear as you can. Put on there the original, put on there if it's a triangle ABC, then the new one is A prime, B prime, C prime. Put that on. Put the list of coordinates of the new ones. You can list them on the graph paper, or you can list them down here in a list, just so that they're all compiled. If it tells you to do it for sure. Even if it doesn't tell you to do it, it's a good idea to do it. Alright, so a similar example 1A, that's on page 472. Alright, number 4 comes from lesson 63, and it is similar to example 3. Again, that is example 3 on lesson 63. The next one is from lesson 67, it's example 2. Lesson 67, example 2. Open your books to lesson 56. Lesson 56. And this is 30, 60, 90 triangles. You're going to have a problem that is going to be pretty much like example 2. That's the top of page 369. Find the perimeter of the triangle. The triangle is a 30, 60, 90 triangle. Give your answer in simplified radical form. We already dealt with this in this previous test, but I'll just say it again. A 30, 60, 90 triangle looks like this. The lengths are in the proportion of 1, 2, and square root 3. That means whatever this number is twice as big. Whatever this number is the square root 3 times bigger than that. If you know this number and you need to get to this number, you divide it by 2. If you know this number and you need to get to this number, you divide it by the square root of 3. But that's the relationship. 1, 2, square root of 3, that's the proportion. You can use that then to solve it. And it is similar to example 2 there on lesson 56, example 2. Alright, the next one, we are at number 7 if you're counting. Problem number 7 is lesson 66, example 3. And let's flip there quickly. Example 66, lesson 3. And it's exactly like like example 3. So we're on the top of page 438. If you study that problem, the very top problem on page 438, it's example 3 on lesson 66. Study that problem, know how to do it, you will get a 100% on that problem in the test. Use the apothem and the perimeter to find the area of this regular hexagon. The problem is it's a regular hexagon, and the only thing you know is the side length of this regular hexagon. Hexagon is 6. The only thing you know is this is 10 or whatever. That's what the book says, it's 10. So probably your test will have some other number other than 10. The same procedure applies. This is 10, 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 this is 10. The reason you know they're all 10 is because it's a regular hexagon. Well, the perimeter is pretty simple. In my opinion, the perimeter is pretty simple to find of a regular hexagon if you know one side length. 10 plus 10 plus 10 plus 10 plus 10 plus 10. It's 10 times 6. The perimeter is 60. There's your answer. The tricky part is finding the apothem, or the little more involved part. You need to know the apothem, that is this perpendicular distance from the center point to the side. You need to know that distance to find the area of this. Because why? Actually, you could. Now I'm going to say this, and then I'm going to try it out quickly, actually. I'm just going to try it out right now. I just thought of something that might be simpler. And that is, if you know this is 10, you could divide this up without even knowing this, but it's not really what it says. It says use the apothem. So use this second method to verify your answer. Let's do it that way. If you divide this all into triangles, never mind, you still need to know it. All right, so cancel that one. No matter which way you go, you still need to, like I was going to just say, find the area of those 6 triangles. Well, you still need to know the height of that triangle, which happens to be this apothem. So you still need to know this. This is the perpendicular distance, so we're back to square one. This is 10 right here. Draw a triangle, and then bring it out here to dissect it further. And you could even do this. This is 10, this is 10. It's a bad drawing, I know. It should go like that more. 10, 10, and then that should go more in the middle, whatever. So if you erase this and just look at half of this triangle, this 10 becomes 5. And you want to know what this is. Well, I just erased this other one, but if I put it back here again, 30, 60, 90 triangle. This is a 30, 60, 90 triangle because it came from a regular hexagon. A regular hexagon has 6 triangles in here, and 360 divided by 6 means 60 degrees for all these middle things. If this is 60 degrees for all these middle things, and this is 10 and this regular, then these are 10 here, and this is 10, and these are 60 down here. So this is an equilateral triangle, 60 degrees on all corners. Now we're bringing this out, and it turns an equilateral triangle into 30, 60, 90. So 1, 2, square root of 3. Whatever this number is, you have to take it times the square root of 3. So this number happens to be 5. This is kind of like 1 since this is proportions. This 1 is a 5, so it's 5 square root 3 is the apothem. And the book agrees with me on that. So now you take the formula for the area of the hexagon, which is 1/2 of apothem times perimeter. Now is where you could actually check then 2 different ways. Once you have this 5 square root 3, you could decide, you can check it by going, finding just the area of this triangle and taking it times 6, or you use the formula. The area of a regular hexagon is 1/2 of the apothem times the perimeter. Is apothem A? Yeah, little a times big P. And it's really doing the same thing as checking all of these times 6. It's 10 times 6, so that 10 times 6 becomes 60 right here. Apothem times perimeter, use the formula and find it. Now they give the answer in square root form. The book actually does not tell you to do that. If you look carefully at example 3 still, it just says find the area. It doesn't say to give it in square root form. So you can, if you want, that 3, it's 5 square root 3, and this answer is 60 here. So 60 times 5 is 150. So it's 150 square root of 3 is the answer for this example 3. 150 times the square root of 3. You can leave it like that. You can give it in a decimal form approximately. I don't care which way you give it, but whichever way you give it, make sure it's right. All right, study example 3. If you have questions on that, you can ask, but It's all based on this 30, 60, 90 triangle with proportions, side lengths being proportion of 1 to the square root of 3. I know I'm kind of going over this, but this is what it is. If you can get that, then you got this problem. All right, we are ready for number 8. Number 8 is from lesson 52, and it's example 1. The next one is lesson 68, example 2. The next one, we're at number 10 if you're counting. Number 10, problem number 10, comes from lesson 72, and it's example 1. 72, example 1. All right, number 11, open your books to lesson 73. Lesson 73, we are ready for problem number 11, and this comes from lesson 73. And it is kind of a combination, so it's not exactly one of these. What it is like example 1. It's on page 483. It is like example 1, where you need to find x, the horizontal distance, but they also give a y on the vertical distance. And it's not a kite, but anyway, it's the same problem. So you're going to have to do it twice. This is sine, cosine, and tangent. This is Oscar had a hold on Arthur. Memorize that saying if you haven't already, and be prepared on the test to recall Oscar has a hold on Arthur and be able to say that the sine is Oscar had, the cosine is a hold, and the tangent is on Arthur. And be able to know what opposite, hypotenuse, and adjacent is. The sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. It's all determined by where you're at in the problem. If you are right here, if you have this this angle measure of whatever, 40 degrees, and you know that this is 100 feet, and you need to find this right here, then your station here, this is where you're concerned from, so your references for these come from this one, which is referenced from this end. This is the hypotenuse, 100 is hypotenuse, this is opposite. This side is adjacent. So if this is what you're concerned with, this and this, you know this one and you need to find this one, then you're looking for an opposite and a hypotenuse, which happens to be the sine. So the sine of 40 degrees is some unknown value x over 100. And then type it in calculator, solve it, however. If you need to know this one, then you're concerned with hypotenuse and adjacent. Again, all these names, except for hypotenuse. Hypotenuse is always hypotenuse, but the opposite and adjacent, the way you determine which one is opposite, which one is adjacent is look at where you're at. You're at this angle and then reference, your world view is from here. So which one is opposite of this, which one is adjacent to this. So you're going to have to do that procedure twice. One time for this length and one time for this length. I'm just actually telling you kind of which ones you'll need. Sine, cosine, tangent, write that down, figure it out from there. Study example 1, and you can look at the rest of those examples as well on lesson 73. All right, we are ready for number 12, and this is flip back to lesson 70. Lesson 70, example 2. So this is really related to a previous one we did. Again, it's a 30, 60, 90 triangle coming into play. And the reason it is because it's example 2 and it says, calculate the total surface area of a regular hexagonal pyramid with a slant height of 12 and a base side that is 3. So hexagonal pyramid, and it's going to give you a base length, a base side, and a slant height. Total surface area, so one thing you're going to have to do is look at the bottom, find the area of the base. Well, that's, again, this hexagon that I just erased, and I can still see it, it's right here. That's the base of your pyramid, and then it comes up from there. So if you would draw it in three-dimensional, which I can't really, then it would, and the point is up here, and it would all come up like this, something like that. But you need to find the area of this base down here, and then the area of all these triangles. And you have to do the work like example 2 says. One thing you're going to have to do is find the area of the base, which is the perimeter. You're going to know that pretty simple. Base side length is 3, and then this slant height here is 18 or whatever the book says, 12. But first things first is find the area of this. Here we are, the same problem. Now we have a side length of 3, and this is a hexagon, so it's a regular hexagon. You got to know this length right here, so take this triangle out. Now your 3 is up here, and your 1.5 is right here. So now it's this weird number, 1.5 square root of 3, but that's okay, just let it there for now. That is the length here, 1.5 square root of 3. They actually take it and say, we don't like that, so we're going to double this number, which means 3 square root of 3, and then divide it by 2. And that is the same as this. 1.5 times the square root of 3 is the same as 3 times the square root of 3 divided by 2, because 3 divided by 2 is 1.5. So it makes it look clunky, but you can do either one, I don't care. That's the apothem. Put that in your formula for finding the area of the base, and you got it. And then you use the total surface area, which is going to be your slant height and your base and all that. So example 2, just study that. It's page 465. All right, the next one is from lesson 37, example 4. And I do believe that it is a repeat. Lesson 37, example 4. It is a repeat of this last test. Yes, exactly. So example 4 is find a line that is perpendicular to another line. In this case, the book, we're on page 239. Your textbook is page 239. You should be studying example 4 on lesson 37. And it says find a line that's perpendicular to y equals 2 over 3x, and it passes through the points 2 and 4. They use the point slope formula. You can use that if you want to memorize another formula. That one is y1 minus y2 equals mx1 minus x2, I think. Or y minus y1, okay, y minus y1 and x minus x1. Who cares if you label them 1 or 2 or not, but so you can use this. You're just going to use, again, you're going to generate a new slope that's perpendicular to the one that's given. In this case, it's 2 over 3, and so perpendicular is negative 3 over 2. You fill that in here, and then you use the points that they give you, 2 and 4, put them in here, and solve it, and you would get some form of y equals mx plus b. But you can use that, or you can simply use this one right here and use the new slope, which was in the book is negative 3 over 2. It's the opposite reciprocal of the one that's given, new slope, and then your x and your y right here. Solve for b. Once you get the b value, then your new line is y equals negative 3 over 2x, and then whatever you found for b, whether it's a negative number or positive number or whatever. You can use graph paper. You can verify by graphing the lines and checking, making sure they go through the points that are given and all that. You can use this one, or you can use this one. So, up to you. All right. Lesson 37 we did. So number 14 comes from lesson 59, and that's the volume of a prism. It's pretty simple. Lesson 59, volume of a prism. All right, we're going to wrap this up soon. Problem number 15, if you're counting, it's number 15. It is from lesson 75, and it is example 2A. Lesson 75, example 2A. The next one is from lesson 57, and it is example 1 or 2. I don't know why actually I say 1 or 2. I guess because I don't want to give you the exact one, but or maybe it's a combination. I'm not actually sure. Lesson 57, example 1 or 2. Again, it's similar to a problem you've already done on in this last test. So find the perimeter of something, a rectangle or whatever, and they're going to give you the coordinates. So This time they do not actually say, give your answer in simplified radical form. I'm perfectly fine if you do. Just repeat the last one that we did over here, this is the last test. You know, it's a distance formula, but it's based on Pythagorean theorem. How many up, how many over, it's this squared plus this squared, and then the square root of that is the answer. Then count them all together, add them up. You don't have to use simplified radical form. You can use decimals, which is fine, either one. All right. Problem 17 comes from lesson 53, example 1. And then problem 18 comes from lesson 39, and that's all I have, lesson 39. I don't know why, but lesson 39 I think is like inequalities in a triangle. It's simply saying that if you have a triangle, then your side lengths correspond to the angle measures. So your smallest angle measure right here is going to be opposite the smallest side, and then whichever angle measure is bigger, it's hard to tell in this drawing, but whichever angle is bigger is going to be the bigger side. So you're supposed to, let's see, I could probably find you an example. It might be similar to example 1A. I think it is. Yeah. So they're going to give you a couple angles in there in the triangle, a couple measures of a couple angles. You've got to find the measure of the last angle, 180 degrees in triangle, and then order the side lengths from least to greatest, or from greatest to least, whichever it says. Put the side lengths in order, and you get that from the angle measures. All right, two more. Lesson 51, example 2. This is problem number 19. It is from lesson 51, example 2. And the last one comes from lesson 74, example 1. Lesson 74, example 1. Maybe turn there. That's one of our most recent, and that is transformations. So lesson 74, example 1. They're going to give you a drawing. You're going to use graph paper. You're going to draw this triangle or whatever figure. This one says reflect triangle ABC across the y-axis. Find the coordinates of the vertices of the reflected image and write the transformation in mapping notation. Remember, the general form is the translation of points x and y becomes something and something. And you can get this after you do it. You can actually do it. So if there's a triangle up here and they say, you know, reflected across the y-axis, then you just check your points and you go across. It's always going to be the same distance from wherever you're reflecting it across. And if you're reflecting on here, it's a bad marker. If you're reflecting it from this line, then it's going to move over, and it's not going to move up or down at all. It's going to stay the same up and down. It's just this movement that changes. Or the same thing if it's here, you know, if you're reflecting across this line, then this movement does not change. There's no movement this way. It's all in this up and down. So reflect it, list the coordinates, and then you should be able to tell what happened. Was it a negative x or was it a negative y? What happened? One of these stays the same if you're reflecting across a line like this. So it's like example 1. Study that and do the transformation. List the new coordinates for your new figure. Put A prime, B prime, C prime if it is A, B, and C, or whatever it is. And then try to come up with a mapping notation, which you can get that at the end if you compare your old coordinates, this coordinate, what happened to the new one, what happened from this coordinate to the new coordinate, and that should tell you what's going on, and put that in mapping notation. All right, if you still have questions after dutifully studying this for today and tomorrow, most of today and most of tomorrow, some of today and some of tomorrow, whatever. If you've made a good effort to study and you're still confused about something, you can try contacting me and asking for further clarification. I don't think I'll promise to answer all your questions, but I will attempt to do my best to answer your questions. Thank you.